Hello everyone, this is Dr. Surya. Today we are going to solve some of the problems on minor head loss or minor energy loss. That is the loss of head due to sudden enlargement and sudden contraction in a pipe. So the first problem is that the rate of flow of water through a horizontal pipe is 0.25 meter cube per second. Diameter of the pipe is 200 mm and it is suddenly enlarged to 400 mm and the pressure intensity is given as 11.772 Newton per centimeter square, and we have asked to determine the loss of head due to sudden enlargement, pressure intensity in the large pipe, and also the power loss due to enlargement. So first we'll write the given data. So the first given data is discharge. So we'll denote our discharge as Q. So Q is equal to 0.25 meter cube per second. Then they have given the diameter of the pipe. So I'll keep the diameter of the smaller pipe. So I'll write at smaller pipe. So small pipe diameter to be D1, which is 200 mm, which is nothing but 0.2 meter. And similarly, it is getting enlarged. So I'll keep that pipe to be the large pipe, which is D2 is equal to 400 mm, that is 0.4 meter. Then they have given the pressure intensity in the smaller pipe. So because I have taken the smaller pipe denomination as 1, I will keep the pressure intensity also as 1, that is P1. For small pipe is 11.772 Newton per centimeter square. So we have to convert it into meter, that is 11.772 into 10 power 4 Newton per meter square. So first thing is that they have asked us to determine the loss of head due to sudden enlargement. So it means that we'll write the formula to be used. So first one is loss of head due to sudden enlargement. The formula is very simple, which is V1 minus V2 the whole square divided by 2G. And so we'll solve one by one, and the next one is pressure intensity. So for that we'll be using our Bernoulli's equation, so we'll write that later. So second one is Bernoulli's equation, and third one they have asked us to determine the power loss, and the equation for power loss is rho GQ HE by 1000. Okay, so these are the three formulas we are going to use in this problem. So the first problem, we'll take the first one, that is loss of head due to sudden enlargement. So which is HE is equal to V1 minus V2 the whole square divided by 2G. So here V1 is also unknown to us and V2 is also unknown to us. So we have to determine the V1 and V2. How can we determine? By using our continuity equation. So our continuity equation is nothing but Q is equal to A1 V1, which is equal to A2 V2. My Q is known to us. So I'll take one equation, that is Q is equal to A1 V1. So in that case V1 will be equal to Q by A1. So Q value is given in the problem. We have to determine the A1 value. A1 is nothing but pi by 4 D1 square. So which is pi by 4 into 0.2 square, that is 0.03141 meter square. Now my V1 will be equal to 0.25 by 0.03141, which is equal to 7.96 meter per second. Similarly, I can get the value of V2, that is Q is equal to A2 V2, V2 is equal to Q by A2, A2 is pi by 4 D2 square, that is pi by 4 into 0.4 square. A2 value is 0.12566 meter square. V2 will be equal to 0.25 by 0.12564. So V2 value is 1.99 meter per second. So the head loss due to enlargement HE is equal to V1 minus V2 the whole squared by 2G. So we have determined all our values, that is V1 is 7.96, V2 is 1.99, the whole square divided by 2 into 9.81. So head loss due to enlargement is 1.816 meter. So this is our first answer. Second answer is we have to determine our pressure intensity P2. Pressure intensity P2. It's very simple. So we are going to use our Bernoulli's equation before and after sudden enlargement. So Bernoulli's equation is very simple, that is pressure head plus kinetic head plus datum head in the smaller pipe will be equal to pressure head plus kinetic head plus datum head plus head loss due to enlargement. Okay, that is the one I am going to write it out. So which is P1 by rho g plus V1 squared by 2g plus datum head Z1, which is equal to P2 by rho g plus V2 squared by 2g plus Z2 plus head loss due to enlargement. And if you check here, the pipe given here is horizontal pipe. It means what? No datum head will be present, that is Z1 will be equal to Z2. So datum head will be there, but both will be equal. So we can omit our Z1 and Z2. So it becomes, now the equation becomes P1 by rho g plus V1 squared by 2g is equal to P2 by rho g plus V2 squared by 2g plus He. Okay. Now we have to determine the value of P2. So we can rearrange this equation as P2 by rho g will be equal to P1 by rho g plus V1 squared by 2g minus V2 squared by 2g minus He. So I am just rearranging the equation, nothing more than that. So now I can substitute all the values. So P1 value is 11.772 into 10 power 4 divided by rho is 1000, that is density, g is 9.81 plus V1 we have determined as 7.96 square divided by 2 into 9.81 minus V2 is 1.99 square divided by 2 into 9.81 and the head loss we have found as 1.816. Okay, now this becomes P2 by rho g is equal to 12 plus 3.229 minus 0.2018 minus 1.8160. Okay, now P2 by rho g I will be getting, after simplification I will be getting this to be 13.21 meter. Now I am in need of only P2. So P2 is equal to 13.21 into 1000 into 9.81. Okay. So if I am in need of centimeter square, because everywhere it is given in centimeter square, that is pressure we are using denoting by centimeter square, and what we get here will be in meter square. In order to convert this into centimeter square, I will be multiplying it by 10 power minus 4. So P2 will be equal to 12.96 Newton per centimeter square. Okay, so only this value if I get, I will be getting the answer in Newton per meter square, and if I multiply into 10 power minus 4, I will get the pressure intensity value in Newton per centimeter square. And the third one is power loss. Power loss is nothing but P is equal to rho g q He by 1000. Rho is 1000, g is 9.81, Q is 0.25, He is 1.816 divided by 1000. I will be getting my P value as 4.453 kilowatt. That is power loss due to sudden enlargement will be 4.453 kilowatt. The next problem is that they have given a figure. So you can see a figure. So this figure is given to you in the problem. Now we'll read out the problem. There is a sudden contraction is introduced in a horizontal pipeline from 50 centimeter to 25 centimeter. So initially the pipe is 50 centimeter and it is getting contracted to 25 centimeter. So if the sudden contraction is taking place, the pressure is also it is changing. That is from 10,500 kg per meter square to 6,900 kg per meter square. So if kg per meter square is given to you, and if you want to convert it into Newton per meter square, you have to multiply it by 9.81. That is 1 kg per meter square will be equal to, I'll write it here, 1 kg per meter square will be equal to 9.81 Newton per meter square. So if you are given, if the given value is in kg per meter square, just multiply it by 9.81 to get the value in Newton per meter square. They might not have give the Newton per meter square value. If that is the case, simply multiply by 9.81 and get the value in Newton per meter square. Now calculate the rate of flow. So we have asked us to calculate the rate of flow Q, and they have given the coefficient of contraction, just assume it to be 0.65. Then following this, if there is a sudden enlargement from 25 to 50 centimeter, so first contraction is taking place, then enlargement is taking place, and because of that there will be a change in pressure too. That is from 6,900 kg per meter square to it is changing to some other pressure. They have asked us to determine what is the pressure at 50 centimeter enlarged pipe, which means they have asked us to determine the P4. So initially the diameter is 50 centimeter, pressure is 10,500 kg per meter square, and then it is getting contracted to diameter of 25 centimeter, and the pressure is also getting varied to 6,900 kg per meter square. Now again from 25 centimeter the pipe is getting enlarged to 50 centimeter, and pressure, what is the pressure variation? So that is what they have asked us to determine. So we are going to consider the head loss due to contraction as well as the head loss due to enlargement. So first part we will solve, and slowly we will solve the second part. So first we will write the given data. So here they have given D1, D2 or all the things is given in the figure itself. Just I am writing it again. So D1 is nothing but 50 centimeter, so which is 0.5 meter. Another thing is that anyway we will be using area formula, so I will be calculating simultaneously we can calculate that area also. That is A1 is equal to pi by 4 D1 square, which is 0.5 square, which is 0.1963 meter square. Similarly D2 is given, D2 is 25 centimeter, which is 0.25 meter. A2 will be equal to pi by 4 into 0.25, which is equal to 0.04908 meter square. And pressure in larger pipe, so P1 is equal to, straight away we can take Newton per meter square value. That will be easier for us because we will be writing everything in terms of Newton per meter square. So which is 103,005 Newton per meter square, and P2 is given as 67689 Newton per meter square, and coefficient of contraction Cc is equal to 0.65. So these are the things that is given to us in the problem. And first thing is that they have asked us to determine the rate of flow. So what is rate of flow formula? The formula for rate of flow is nothing but Q is equal to A1 V1 or Q is equal to A2 V2, whatever may be. We can use any of the things. A1 value is known to us, V1 value is not given, and similarly A2 value is known to us, V2 values are known to us. So we have to determine the V value, either V1 or V2. We have to determine that, and then only we can get the rate of flow of water. So in order to do that, what we are going to do is, first we will determine the head loss due to contraction, because the pipe is getting contracted from 50 centimeter to 25 centimeter. So the formula for head loss due to contraction is V2 squared by 2G into 1 by Cc minus 1. So V2 square is unknown to me. So V2 square by 2G 1 by 0.65 minus 1. So the head loss due to contraction will be 0.2899 V2 squared by 2G. I'll keep this as equation number 1. Okay, because V2 is not known to me. So that is a major thing. Now, I don't know the value of V1 also, but we can easily establish a relationship between V1 and V2 using our continuity equation. So it's going to be very simple. That is from continuity equation. A1 V1 will be equal to A2 V2. Okay, or V1 will be equal to A2 V2 by A1. Okay, so I can establish this very easily, and similarly this will be equal to pi by 4 d2 squared into v2 divided by pi by 4 d1 squared. So I can cancel it out. So v1 will be equal to 0.5 by 0.25 the whole square into v2. So from here I will be getting my v1 will be equal to v2 by 4. This I will keep it as second equation, or directly you can substitute your a1 a2 value and you can get the relationship between v1 and v2. Now I am going to apply the Bernoulli's equation, because there only I will be getting my pressure head, my kinetic head, my datum head, and as well as the head loss due to contraction. So Bernoulli's equation where I am going to apply is at the section 1 as well as section 2. That is P1 by rho g plus V1 squared by 2g plus Z1, which is equal to P2 by rho g plus V2 squared by 2g plus Z2 plus Hc. So if you see here, Z1 and Z2 will be equal, since because the pipe is horizontal, both the values will be equal. Z1 is equal to Z2. So I can omit that. So it becomes P1 by rho g plus V1 squared by 2g is equal to P2 by rho g plus V2 squared by 2g plus Hc. Okay. Now I can substitute the values. That is, I can keep this as equation number 3 and substitute 1 and 2 in 3, which means the equation number 1 is Hc value, equation number 2 is instead of V1 I can substitute the V2 value. So it becomes P1 value is divided by 1000 into 9.81 plus, instead of V1 square I can substitute V2 by 4 the whole square divided by 2 into 9.81 or 2g, which is equal to 67689 divided by 1000 into 9.81 plus V2 squared by 2g plus 0.2899 V2 squared by 2g. On simplifying this, I will be getting 10.5 plus V2 square. 4 square is 16, so I am writing here 16 into 2 into 9.81, which is equal to 6.9 plus both are V2 squared by 2g, so which is 1.2899 V2 squared by 2g. Okay, now I can group all the terms here. That is, I can bring all the V2 squared one side and all the things on the other side. So which becomes 10.5 minus 6.9 is equal to 1.2899 V2 square by 2g minus of 1 by 16 v2 squared by 2g. Okay, now this becomes 3.6 is equal to 1.2274 v2 squared by 2g. 1.2274 v2 squared by 2g is equal to 3.6. So v2 square will be equal to 3.6 into 2 into 9.81 divided by 1.2274. Now v2 will be equal to root of 3.6 into 2 into 9.81 divided by 1.2274. I'll be getting my v2 value as 7.586 meter per second. So I've got my v2 value. So easily I can get the value of discharge. Q is equal to A2 v2. A2 we have determined already as 0.04908 into 7.586. So Q value is 0.3723 meter cube per second. If you are in need to convert it into liters per second, you have to multiply by 1000, which is 372.3 liters per second. So now our first part is over. Second part is we have to determine the pressure due to enlargement. So how much it is changing. So we are going to follow the same Bernoulli's equation, but we are going to apply the Bernoulli's equation in section 3.3 and 4.4. Apply Bernoulli's equation in 3.3 and 4.4. So which is P3 by rho g plus V3 squared by 2g plus Z3 will be equal to P4 by rho g plus V4 squared by 2g plus Z4 plus head loss due to enlargement. Okay. Now, as you all know, Z3 and Z4 will be equal because the pipe is horizontal. Okay, we can omit that. Now, V2 and V3 will be equal because you can see in the figure. If you see the figure, so D2 is 25 centimeter and D3 is 25 centimeter, pressure is 6900 and here also the same. So D2 and D3 are same. So if that is the case, V2 will be equal to V3. Okay, so we are going to use this formula, this relationship in our Bernoulli's equation where we are applying it at section 3.3 and 4.4. So as I have told earlier, V2 will be equal to V3. So that is equal to 7.586 meter per second. And similarly, V4 and V1 will be equal. So that is we have established a relationship between V1 and V2 as V1 is equal to V2 by 4. So which is 7.586 by 4. That is equal to 1.8965 meter per second. Now pressure value is given to us already, which is P3 is equal to 67689 Newton per meter square. So next is that we have to determine the head loss due to enlargement. The formula will be V1 minus V2 the whole square divided by 2g. Here it becomes V3 minus V4 the whole square divided by 2g. So which is equal to 7.586 minus 1.8965 the whole square divided by 2 into 9.81. So head loss due to enlargement is 1.65 meter. Now we can substitute all the values in the Bernoulli's equation. So first thing is P3 by rho g, that is 67689 divided by 1000 into 9.81 plus V3 squared by 2g, that is 7.586 squared by 2 into 9.81, which is equal to P4 by rho g. So P4 is the one we are going to determine, so I'll keep it as P4. P4 into 1000 into 9.81 plus V4 squared by 2g, that is 1.8965 square by 2 into 9.81 plus head loss due to enlargement, that is 1.65. This becomes 6.9 plus 2.933 P4 by 1000 into 9.81 plus 0.183 plus 1.65. So I'll keep the P4 term alone and all the term I am rearranging it, so it becomes P4 by 1000 into 9.81, which is equal to 6.9 plus 2.933 minus 0.183 minus 1.65. So I'll be getting this value as P4 by 1000 into 9.81 as 8. So my P4 value will be equal to 8 into 1000 into 9.81. P4 value will be 78480 Newton per meter square. Thank you and happy learning.